Alright, we're going to program the UCF fixture plate, or not fixture plate, the actual part that we drew earlier. Create a new job. Default is square stock, so take that drop down, pick cylindrical. Then we're going to highlight that box, pick a radius that we want it to go around. We'll pick stock radius, and then we're just going to tell it the radius of the stock that we're using. It's going to be 5 inches, so 10-inch diameter. So here we're going to pick the top face for it to, as far as Z to go up. As you can see, it didn't pick the top face. Must have picked something because you're so far away, so I'll just zoom in, pick that top face right there. That'll put the Z going up. Then the box, it's the drop down is under. It lets you pick where you actually want that your work coordinate system to be placed at. You need 1 and 1. Top plane, mid plane, bottom plane. Whether you want it, mid plane, mid section, right side. Whether you want mid plane left section, bottom left corner, or whatever you want. Here we're going to use top plane, or the top face, center of the part, and then we use a Renshaw probe to pick it up. There's 2 little circles you see on the sides of the part, so it's just to demonstrate how we got the dowel pins on the fixture plate. So you just bump our 10-inch round up against it, clamp it down, so once we've set that origin one time, we don't have to go back anymore and pick it up. It'll be set for every single part. And then we'll do the same with the fixture plate. That way it's set for every part. So we'll create a new tool, flat end mill, 1/2 inch. Again, you got all the options for your length, flute length, shank diameter. You can even set up different tool holders and stuff. And that stuff would matter if you were trying to get into super tight places, things like that. But for this, it really doesn't matter. So here we're in our passes tab. So now we're going to go into HSMWorks. Top drop down, we're going to pick our material, 6061 aluminum. Solid flat end mill. Your how far the tool's sticking out, your flute length, and then you got helix angle, your chip diameter. This is going to be the actual size of your tool. Corner radius if you're using a bull nose. And that's your depth to cut right there. Next to your depth to cut is going to be your width to cut. And then click the radial chip thinning button, because that's going to increase your feed rate right there. Now instead of a width to cut, we're going to tell it to do 35 degrees of the cutter diameter, which is going to end up being about 55,000, something like that. Which that's our step over. So we're going to go 900 thousandths deep, 50,000 step over, which is still being conservative. We could go higher than that. Now we're dialing back the feed rate. You got an S and an F right there. One spindle speed, one speed. So we'll go up and change the RPM to 7,500. That way we've got some override left in it. You could really just bump your feed rate down and do the same thing as overriding your spindle, but this is how I do it. So now we'll go back to SolidWorks or HSM, and we'll put in the same numbers we just calculated in HSMAdvisor. It should be 50,000 step over, 900,000 depth to cut, So it leaves 0 stock. We'll leave the machine cavities button click because we're trying to machine inside the work. Now we're going to go into the tool and we're going to tell it all the RPM, the feed rate that we just calculated, the helical ramping rate, the plunge feed rate, lead in, lead out feed rate, the ramping spindle speed if we wanted to have a different RPM running on the spindle. We can do all of that right there in that option. You can also do it in the tool library, but if you do it in the tool library, those options are going to go for every operation of that tool. And you know, what you're running radial chip thinning at is not going to be the same that you're running a slot at. You know, if you're pocketing, you know, in a slot or something, cutting on, you know, 180 degrees, the tool have to, you know, the whole face of the tool be a whole different ball game there. So now we're going to go in and do the contour, pick that bottom, the very bottom radius. Click the reverse button. Now you can see that that's not working, so we're going to hit abort, because on this operation we're only machining the inside. Then it goes to the fixture plate for the outside, so we don't want the outside operation. You know, we don't want it machining the outside and the inside in the same operation. We want to be able to split those up. So instead of, you know, before we didn't have a boundary, now we're going to go from selection in the very first or second tab and confine the tool to that boundary. You can also give it an offset from the boundary. If I wanted to go 100 thousandths past the boundary, or 200 thousandths past the boundary, or 100 thousandths inside the boundary, you can do that as well. Now we're doing the second contour. Again, we're going to pick the inside lower edge, you know, right where the two faces meet at. Another contour. Basically just rinse and repeat, right? Pick that top, you know, where the two faces meet on the top lip. Hit reverse, since we know that it needs to be reversed every time on the inside right now. And we can see we got another problem. Somewhere I screwed the pooch on my when I put in my width to cut, because each blue line ought to be just the center of the radius, or the center of the cutter, right? So for it to be solid blue like that, that thing's barely stepping over. You know, you should see actual lines that are not just solid blue color. So we'll hit abort, go back in and edit this operation, and see what the hell we got going on there. First we'll just finish, you know, what we're doing now. So we'll create our contour. You just can't forget to go back and change that. We're going to create another contour. This time we're going to create a new tool. It's going to be chamfer mill, 1/4 inch, 10 thousandths tip diameter. I'm at home, so I'm just pulling out my rear right now. Pick that lower edge right there. Shouldn't have to do anything in that tab. Just leave it where it's at. And those two tabs right there, those are going to be additional additional offsets above what it's calculating. I don't know what happened there. Again, that's all additional offsets, so you shouldn't have to touch that unless you want it to go, unless you want a little more tip offset, you need to bump the tool further in or further out to hit the number that you're trying to hit, or something like that. Now we're going to simulate it just to make sure that it's dropping in how we want. It's not actually feeding into the work. We want it to be cutting into a chamfer. So it looks like it's stopping. It's not going too deep. Looks like you still see the edge of the where the taper begins. Looks like it's cutting. Now we'll go back into this one and see what the hell we did wrong there. So we go back to the passes tab and look at our radial offset. So we come back over here and look at our width of cut, and we'll go back over here and compare those numbers. And we'll go back to SolidWorks rather. There's a problem right there. Instead of 50, we've only got it for 5 thousandths. So I added a zero, an extra zero in front of my 5 is what I did. Now you can see the actual lines in there. And again, that's conservative. We could step over even more than that, I would imagine. So let's go ahead and stock simulate the whole thing. Let's see what she's going to do. You see it machine down on that first pocket, then it step itself up, and then it'll step itself up again. There you go. It's going to drop back in. And it'll come in and do the contour. So the finish, then it's going to come in and with chamfer. And that little box right there, it'll tell you if you've got any crashes, clashes, flutes hitting stock. It'll tell you what tools are moving what stock. And that little box I just clicked there, that blue is showing you the stock that you got left. If it's not blue, then that means everything's been machined. So the only stock we got left is the outside of the part where we don't need it. So now we're going to create another job. Now this is the job for the fixture plate. That way we can just post-process one job and the other. Same thing, cylinder. Pick it, tell it what you want it to be concentric to. Stock size. 0 offset and a Z. Same thing, I'm going to pick the top face, double center of the part. It's already in the center of the part. Click our check mark. Another adapter. Tool library, pick our 1/2 inch. It's already highlighted. Just hit select. We'll do all the speeds and feeds to match, the other operation. Same with depth of cut, width of cut, all that. It'll all be the same. Only difference in this tab really is we're going to click the machine cavity so it's not highlighted, because we don't want to machine inside the part. We only want to machine outside the part now. So we'll go ahead and click our check mark. Go to contour, create a contour. Click the bottom edge. Click the check mark. See if you have to reverse it or not. Nope, it's on the outside. Go back to contour, create another one. Pick the next edge, inside edge. Check mark. Contour done. Create another contour. Go to the library. Pick our chamfer tool. Select OK. We don't even have to go to the box really. We're just going to pick the bottom edge of that chamfer and it automatically moves to the next tab. Click OK. Go back and create another contour. We've already got the same tool by default, so just click that bottom edge, click OK. Now we'll go to stock simulate, see how she runs. I'll slow the simulation down so we can see the contour operations and stuff. So there's one contour, two contours, chamfer contour at the bottom, chamfer contour at the top. And that's going to be the end of that.